oxidation state of oxygen different from its value in water? Question mark. This is a jump question. This is a jump question. This is a jump question. A. Hydroxide ion. B. Water, or rather hydrogen ion. C. Oxygen ion. And D. Hydrogen peroxide. Now, when you look at this question, in which of the following is the oxidation state of oxygen different from its value in water? I want you to understand that last time, or in my last video that I made, I told you about the rules that guide us in calculating oxidation number of an element in a compound. And one of the rules that I told you is that the oxidation number of oxygen is always -2 in ordinary compound and -1 in hydrogen peroxide and -0.5 in superoxide. It simply means that when you look at this problem, there's no need wasting your time solving it. There is no need trying to calculate the oxidation number of this oxygen in the various elements and compound or ion and the radical. You just have to know that the answer is D. Simple as that. Now let us look at example 2. This one we have to be very careful, and our understanding of oxidation number will help us in solving it. It is also another jam question. It is also another jam question, and the question goes like this. The question goes like this. It's a very easy one, solvable one. It goes this way. It says, which of the following equation represents an oxidizing action of sulfuric acid? Example 2. Which of the following equations represents an oxidizing action of, and here they give us sulfur dioxide, just like this, sulfur dioxide, and they gave you options to choose from, and they said A. They gave us this plus 2NHNO3 to give us H2XO4 plus 2NO2 plus heat. Isotonic reaction. B, we have 2XO2 plus 2H2O plus O2 to give us 2H2XO4. And 3, we have, or C, rather, we have XO2 plus 2H2O plus Cl2 to give us H2XO4 plus 2HCl. And lastly, the option we have SO2 plus 2H2S to give us 3S plus 2H2O. Now, how can we solve this problem? It's not something that you have to rush. You just have to apply what I told you last time in solving oxidation number of the elements in the compound and applying the rules I gave you, which I told you that in number 3 in my definition previous, I said that an increase in oxidation number simply means that an element is undergoing oxidation, and a decrease in oxidation number simply means an element is undergoing reduction. And any increase, any element that is undergoing oxidation is itself a reducing agent, and any element that is undergoing reduction is an oxidizing agent. And oxidizing agent loses electron, reducing agent accepts electron. So now, if you look at this first one, A, if the oxidation number of this whole compound, because the neutral compound is equal to 0, but the oxidation number of sulfur here in this compound is 4. How do I know? Because I know that 2 oxygen here has minus 2 oxidation number, which is one of the rule, because this is not a peroxide superoxide, it's a neutral compound. Now the 2 times minus 2 is minus 4. Definitely 4 minus 4 is equal to 0, because the algebraic sum of the oxidation number of a neutral compound is equal to 0. So if this sulfur here is 4, now let us look at the sulfur here. Definitely this is sulfuric acid, this is oxosulfate 6 acid. The oxidation number of this sulfur here is 6. So now 4 to 6 is decrease, and that means it is undergoing reduction, and making this any particular element that undergoes reduction is itself an oxidizing agent. But the question says, which of the following equation represent an oxidizing action of sulfur dioxide? Oxidizing action. Now, this sulfur here is moving from 4 to 6. Increase in oxidation number. And increase in oxidation number is what? Oxidation. And definitely it is a reducing agent. Now, look at this sulfur here. This sulfur here is also 4, while this sulfur here is 6. Also, increase in oxidation number, it is also a reducing agent. Look at this sulfur here. This sulfur here is 4, and this sulfur here also is 6. Also a reducing agent. Now, look at this sulfur. Let us be specific now. This is like saying oxidation. Let us look for this oxidation of this sulfur. This is, let's call it X plus oxidation number of oxygen, which is minus 2. Now, which is, because this is diatomic, so we say 2 bracket minus 2, which is equal to 0. Definitely, you have X minus 4 is equal to 0. X is equal to 4. That means the oxidation number of this sulfur is 4. Now, what about this oxidation number of this sulfur here? This is a neutral element. And one of the law I told you last video is that the oxidation number of a neutral element is equal to 0. So definitely the oxidation number of this sulfur here is 0. So what does that mean? There is a decrease in oxidation number from 4 to 0. What does that make this? It makes this guy reduction. It is reducing. Reduction. And we say any element or compound that is undergoing reduction is itself a reducing agent, is itself an oxidizing agent. So it simply means that D is the answer. Now, let us look at another example that I have here, a very interesting example, which is okay, let me clean this. Let me clean this. All right. The question says, which, okay, ion is like number 3, example 3. The question says, ion Fe solid plus Cu 2 plus aqueous. to give you Fe2 plus aqueous plus Cu as copper solid. Now, the question says A ion is the oxidizing agent. B says ion is reduced. C says copper 2 ion loses electron. And D says copper 2 ion is the oxidizing agent. So, another simple but technical one, how can we get the answer of this question? Very simple. Look at it this way. Now, this ion is just a neutral element, meaning that the oxidation number of this ion here is 0. Now, it moved from 0 to +2. What does that mean? Oxidation, increase in the oxidation number of an element. Oxidation. Now, it simply means that this ion is the reducing agent because any element that undergoes oxidation, it is a reducing agent, meaning that it can donate electron. Now, look at this copper. Copper 2 to copper in its neutral state, +2 to 0. That is decrease in oxidation number. Simply means it is a reducing agent. And in this case, it is undergoing reduction, meaning that it is an oxidizing agent because it is undergoing reduction. So that means it can lose electron. So in this case, if you look at the option, ion is the oxidizing agent, ion is reduced, ion 2 plus loses electron, copper 2 plus